Now see, this whole thing becomes the stage 1 design. Now like similarly you have to go through stage 2 and stage 3. So I'll just tell you quickly what all things will change. When you go to stage 2, I will be 2. Passband does not change, it will be exactly same. Stop band formula will change. It will now be f greater than, it will be f2 minus f stop less than equal to, this will be f1 by 2. So you will calculate the new stop band, you will define the transition band, you will calculate the normalized transition width as per the values of fp and f stop that you get for that current stage. And finally delta p2 will be exactly same as delta p1 because the formula does not depend upon I. Delta s2 will be same as delta s. When you put the values here, you will get the value of m2. So I will quickly show you the steps for stage 2 and stage 3. The explanation will be exactly same as what we discussed for stage 1. So stage 2 calculation, passband will not change. Stop band, let us see how stop band is going to change. Stop band will be, I will use the same formula, fi minus f stop less than equal to f less than equal to fi minus 1 by 2. And this will now mean that it is f2 minus f stop less than equal to f less than equal to, this will be I minus 1, I is 2 now, so 2 minus 1 will be f1 by 2. And if you solve this, you will get 1.5k less than equal to f less than equal to 4 kilohertz. So if I quickly draw the filter characteristics, this is how it will look like. So passband will start from 0 and it will this time stop at 4. It will always stop at 450, but stop band will start this time from 1.5k because stop band comes out to be 1.5k. It will end at 4k, but we are not interested in that. All we require is the gap between passband and stop band, which is the transition band. Let us now go to step 3. So step 3 will be nothing but delta f2. Delta f2 will be maximum frequency minus the minimum frequency. In this case it is 1500 minus 450 divided by input sampling frequency. Input sampling frequency will be nothing but, in this case, 8000, because before stage 2, if you remember, the input sampling frequency was nothing but 8 kilohertz, which is f1. So this is nothing but the value of f1, which we have also used here. f1 by 2, 8 by 2 becomes 4k, and this will come out to be approximately 0.131. In step 4 we will write delta p2, which will now never change. It will be exactly same as delta p upon 3, because 3 is the number of stages, so that is 3.33 into 10 raised to minus 3. Delta s2 is always equal to given delta s, so that also doesn't change. And in the final step, which will be step number 5, we will calculate the filter length m2 using the same formula, which goes something like this: minus 10 log of, this time delta p2 into delta s2 minus 13 divided by 14.6 into delta f2 this time plus 1. So if you solve it, this time m2 will come out to be 22 point something, so it will be approximated to 23. So that should be the length of H2n. So this is your stage 2 calculation, and similarly I hope you guys can now go through stage 3. I will just mention the final answer. Stage 3 means that I will now be equal to 3. All the formulas and everything will be exactly same. I'll just mention quickly all the points one by one. F stop will not change, so it's between 0 and 450 hertz. Stop band, this is pass band. Now stop band will be a new value. It will be 0.5k less than equal to f less than equal to 1 kilohertz. Going ahead, if you calculate delta f3, it will come out to be 500, which is the f stop, and 450, which is fp, which is always same, divided by input sampling frequency will be 2000 in this case. This will come out to be 0.025. After that, delta P3 will not change, 3.33 into 10 raised to minus 3, and delta S3 will always be 0.001, which is as per the given stop band ripple. And finally, when you calculate the length of the filter, this time your final answer will be 116. So this is the final complete design of 3-stage decimator. You may have design of 2-stage decimator where you will go through stage 1, stage 2 calculations. You may have 3-stage design as well. Make sure that when you do this in the exam, you show all the steps properly and all the values properly.